So this video is going to go over this in-class worksheet on percent composition and empirical formulas. And so our first question says, what is the percent composition of each element in the mineral forsterite, Mg2SiO4? And so if we have to find the percent composition, right, we're going to need the percent composition of each. One of the first things we're going to need to do is find the molar mass of our molecule. And so we can do this by adding up the molar masses of all the atoms. So you can do this on your own, but confirm that you should get 140.71 grams per mole. So that's our molar mass of the whole compound. Now, what we're going to do next is we're going to find the mass of each element in 1 mole of our sample. So if we have, we'll say find mass of each element in 1 mole of sample. And so we can start off with our magnesium. So our percent magnesium, right? What we're going to do is, or actually I'll rewrite this. So we'll start off just with magnesium. And from our formula, we know we have 2 moles of magnesium. So that 2 came from right there, there's 2 of those in our formula. And all I'm going to do is find the mass of that. So I'm going to multiply 2 by the molar mass of magnesium, 24.31 grams per 1 mole. So we're just multiplying each of these by its molar mass, and I get 48.62 grams of magnesium. So I can do silicon next, and here we have 1 mole, Si, multiplied by its molar mass, 28.09 grams. Again, this is from the periodic table. And we end up with 28.09 grams of silicon. And then finally we have our oxygen. And here we have 4 moles of oxygen. And oxygen has a mass of 16.0 grams for every 1 mole. And so we end up with 64.0 grams of oxygen. So that's the mass of each element. So next, using this, we can now say find mass percent. And all we're going to do is we're going to take, for magnesium, the mass we found, 48.62 grams, divided by, and everything is divided by the mass of 1 mole of the entire compound, 140.71, times 100, times 100, and so this was going to equal 34.6% magnesium. Same thing for silicon. So again, we can do 28.09 grams divided by 140.71 grams times 100, and I get 20.0% silicon. And finally for oxygen, 64 grams over 140.71 grams times 100 equals 45.5% oxygen. So here are the mass percents of your 3 elements in the mineral Mg2SiO4. In part 2, we're going to go the other way. So in the second question, we were given a sample of the mineral dolomite, and we were told the mass percentages of calcium, magnesium, carbon, and oxygen. What is the empirical formula? All right. So in this case, whenever you're given the mass percentages, the easiest way is to start off and say, let's assume we have 100 grams of our sample. And then we're going to find moles of each element. So if I had 100 grams of sample, then we know we'd have 21.73 grams of calcium. Now I'm going to divide by the molar mass. It's the reverse process we did before. So look up the molar mass of calcium, 40.08 grams, and I get 0.533 moles of calcium. So I'm just going to go ahead and do this for each. So magnesium, 13.18 grams, divided by the molar mass. Look that up, 24.31. So when we divide that, we get 0.542 moles of magnesium. Carbon, we have 13.03 grams of carbon divided by its molar mass, 12.01 grams, and we get 1.085 moles of carbon. And finally, of oxygen, 52.06 grams of oxygen divided by 16.0 grams per 1 mole of oxygen. And here we get 3.25 moles oxygen. Now that we found the moles, what we're going to do is divide everything by smallest moles. And so what I mean by that is for calcium, I'm going to do 0.533 divided by 0.533 because that's the smallest, and I get 1. I'm going to go down the line. Magnesium would be 542 divided by 0.533, which within rounding, we need to round these to the nearest whole number, 1. For carbon, we get 1.085 divided by 0.533, which equals 2. And for oxygen, we get 3.25 divided by 0.533, which equals 6. So now we have the mole ratios, and so we can say our empirical formula is calcium, magnesium, carbon, 2O6. So this would be the empirical formula of this dolomite. Now, that might look a little strange to you. It's a perfectly accurate empirical formula. I could rewrite it a different way if you've taken any geology or other chemistry courses, and we could write it as calcium CO3 or calcium carbonate and magnesium CO3 magnesium carbonate. This is the same written out, 6 oxygens, 2 carbons, 1 calcium, 1 magnesium, but this is showing the structures form. This is all you need to get to answer the question. Thank you.